All right. So here's the problem I just created. Can somebody help me out with the first step here? What's a complete ratio that I can make?
Sine 12/7.
Yes. All right, now somebody help me out. What's the only thing that I could really discover immediately?
Sine of angle B.
Yeah,
Or sine B.
B, because I know side B. I don't know shit about A, so I can't do anything with A yet. But I can certainly set up the thing for B. Sine of angle B divided by its side. All right, now take a minute and figure out what B is. Don't say anything. Just see if you can figure out what B is. Let's see if Jeff made a problem that makes any sense. All right, pass Jeff. Very recently passed Jeff. All right. Yay, Jeff did it. Dun, dun, dun. So again, don't let this be that big of a deal. I'm going to multiply the 15 up, and then I'm going to take an inverse sine. Shaboop. Inverse sine, and so that means I'll solve for B. I'll have B by itself. So this is what you got to plug in to your calculator. Can you guys do that is the question. Does anybody have the answer?
26.5.
Yeah, 26 point, 26. I don't know. Did the instructions say, did they say nearest 10th everywhere? I forget. Yeah, we'll do on Zoo 26.5. Sure. Degrees, right? Taboo. So what's the possible other angle that might work? What could be, what's the second option? And let's see if it's a viable option. What could the other one be? What could it be?
$150.
3.5.
Yeah, you just have to do 180 minus. I really desperately want you guys to understand this. If this is a reference angle in the second quadrant, and all right, I really, really get this. All the possible angles for a triangle live in the first and second quadrant. Does everybody understand that? Right? The biggest an angle in a triangle can be is not quite 180. It's almost 180. And the smallest an angle in a triangle can be is right next to 0. You guys all with me? So between 0 and 180 are all the possible angles in a triangle. Yes? So when I do inverse sine, the answer I get could actually be a reference angle over there. That's all this is. So what this other angle here could be is just 180 minus what we got. That's it. So like you guys are saying, that would be 153.5. Is that what you guys said? Is that what I'm saying? I think that's what I'm saying. Yeah. All right. Does that work with the angle that we know? Sorry, that's from that problem. From the angle that we know there. Is this viable? Does it work with this angle? Yes, it does, because this plus this would leave something over for this. So over here, all right, please, dear God, I feel like we just logged in, and I feel like I've lost everybody like immediately. And if that's true, you can let me know. It's fine. You can let me know when that happens. It's fine. So we did this, and we figured out angle B could be this. If angle B is this, what is angle A gotta be? Because I know angle B, I know angle C. What does angle A have to be then? If angle B is 26.5 degrees, the other angle is 12 degrees, what's left over for angle A?
Big.
Who?
Bigger than right. 90.
Who cares? I don't care. What is it? As long as it's smaller than 180 degrees, right? That's all good.
141.5.
141.5, maybe? I don't know. I really didn't do it in my head. Let's see. 30, 38. That sounds about right. Yes, that's right. Okay. All right. So, and then you have to finish this out. You have to figure out what side A is. You'd have to finish that out. Now, over here, if B2 is actually this, what would A have to be in this event? Well, what's 153.8? Is that what that says? No, Jeff, you can't read your own writing. Time to retire. 153.5 plus 12. How much does it leave over for angle A?
14.5.
14.5. Okay. And then you have to figure out what angle A, what side A is in this case. And let me see if I could push this a little bit for anybody who's still listening to me. What this physically means is that instead of the triangle being like this side would swing in and it would be like that. And see how angle B is now huge? Do you guys see how angle B is now huge? That's exactly what we discovered. And over in this triangle, angle B is much smaller. That's exactly like I had on the board when I was swinging that little piece on the board. It's exactly the same idea. That's what happens with these freaky ass 2 solution problems. So I'll bet you anything that 21 has exactly that happen, right? Is that good?
How did you get the second angle again, the 14.5?
How do we get this one?
Subtraction.
Yeah.
Yeah, we just said 26.5 plus the 12 and how much is left. So here we do 153.5 plus the 12 and how much is left.
Okay, cool.
So it doesn't change. It's just that one option for B leads to one option for A. The second option for B leads in the exact same way to a second option for angle A. Because the angles interact in the same way. The angles don't give a shit what each other are. They interact in the same way. Does that? So the numbers don't change what I do. Okay. Now, if I did this and there was nothing left over, like if I added B and this and it was bigger than 180 already, that would mean that there's only one solution. Ouch. Does anyone want to see what it would look like if we had no solution? Okay.
Yes.
Has everybody got what they want from this?
Yes.
I'm going to change.
At least I have.
Yeah, the spokesperson has spoken. I'm going to start erasing this and see if anybody screams at me. All right. If you scream now, it's too late. I don't care. So I'm going to change one thing and it's going to destroy this problem. It's good to be the math teacher. I got all kinds of power. I can destroy problem. Rah. All right. So what I'm going to change is this number. I'm going to make it 1 just to be really extreme. Become a blue 1. Okay. So isn't the first step the same? All I did was change the number. So the steps don't give a shit what the numbers are. So I would still do sine of 12 degrees divided by its side, right? Make that ratio equals sine of B over 15. But now try to do this. Yeah, buddy. See what you get. See what you get. Sorry. I'll calm down. So if you multiply by 15, You get sine B equals 15 sine 12 over 1. I don't know why I keep putting over 1. So then I can do sine inverse and kill this. Sine inverse. So if I plug this in, I'll get what B is. Does anyone want to share what you're getting? Anybody? Did anybody try it?
Error.
Yeah, what's it say specifically?
Syntax error.
Oh, syntax error is not good. That means you made a mistake. I think. Let me see. Because I did it in a little bit different way. Let me do it this way and make sure that. Yeah, it doesn't say syntax error if you did it correctly, but it does give you an error. Does anyone get the error?
Oh, domain.
Yes, domain error.
Yeah, same.
Now you guys tell me this: when I put something in to inverse sine, what does that represent? The answer will be what? What's the answer to an inverse sine? You could do it. In fact, what do we, when we do it in inverse sine, what kind of answer did we get? An angle. So the answer to an inverse sine is an angle. So the input to an inverse sine will be the output that we would get for sine. Is the output for sine bounded? Of course, right? What's the output for sine? What do they have to live between? Sine goes from what to what?
Minus pi over 2 to pi.
No. You're thinking about the output of inverse sine. I'm talking about the input.
Minus 1 to
Yeah, minus 1 to 1. Right? So if you put a number in here that is less than -1 or greater than 1, it will say there's a domain error because you're trying to plug something in, an element of the domain that doesn't belong to the domain. It's a domain error. I love that the calculator differentiates the types of error. All right, it might just be me. I understand. Austin sort of agrees, I think. All right. Most of you are just white letters on a black background. But that's okay. Don't worry. That's fine. Okay.
Can I ask you a question from practice quiz?
Yeah, sure. Hold on. Everybody got this? All right, I'm going to stop sharing. Let's see what happens. All right. So what are we looking at? Oh, wait. Let me do this first. I got to do Ayam's question because let me go back to the book. I kept skipping Ayam and now I got to come back. Okay. So 10, 1, 33, 36. Okay, let's take a look here. And then I'll come back to you, Rio. Okay. So in here, these?
Yeah, some of these.
Okay. All right. All right. So, all right. So let's look at 32, for example. From just the information they give us, right? Let me go ahead and call this A just for no reason at all. I'll call this B just for no reason at all. All right. Just because I got to pick something, right? From the information they give us, does everybody understand what I mean when I say make a complete ratio? Is there anyone that doesn't understand what that means? You can private message me and say, damn straight, I don't have a freaking clue what the shit you're talking about, Jeff. You can private message me that right now. Does anybody not understand what I mean when I say make a complete ratio for law of sines? Okay, I don't see any chats. This is your time to say that kind of thing to me. If you just want to, you can blow off some steam. Okay. From just what they told me, can I make a complete ratio in here anywhere? Do I have an angle with its side?
No.
No, not from what they told me. I don't have this guy's side. I don't have this guy's side. But what saves me? Can I figure out the angle I don't know? Can I figure out B?
Yes.
Of course I can. So Ayam, can you tell me what this angle is?
Oh, w- it's angle B gonna be sine of B over 6.
No, stop.
Oh,
I don't want any of that shit. I want you to tell me a number. You know what angle B is. You know what it is. The number. What is it?
oh, it's gonna be 100 minus 120 and minus 25, right?
Yeah, 180 minus those. Okay, sure.
Oh,
And
yeah, it's gonna be 60, 35.
35. Good. Now, can I make a complete ratio? Hell yeah. Right? Right. So now I can set up sine of 35 degrees to 6. And apparently they only want to know the side. Is that the whole deal? I don't know. I didn't read the instructions. Bad, Jeff. Sine of 25 over x, and then you solve that for x, and then you get the answer, and you're done. Yay! So let's see. I think most of the ones I just looked at really quickly in this section are all the same. I'm going to clear this away. Is that all right? Does everybody have what they want from that? I'm going to clear it away. All right. Bye. If I scroll down, they give me 2 angles here. 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 So do you see what I'm saying, I am? They're all the same. You can figure out what that last angle is, which means you can then make a complete ratio. No worries. Yes? Just like we did with 32. They're all like 32. I could have picked any of them. Is that okay? It's okay if you could just say no if that's not okay. It's fine. I'm not gonna cry.
No, it's okay, but
Okay.
what about if they didn't give you like 2 angle, like they just give you 2 sides and 1 angle? I think 39 is they give us 2 sides. I'm not sure about
39. Okay. Yeah, they give me 2 sides, but do
1
you
angle.
have a side and its angle that's across from it?
Yeah.
You do. So that's not an issue, right?
Oh yeah. I just got it. Okay. Thank you.
These were an issue because it looked like I didn't have a side, an angle across from a side, or at least some of these anyway. Like here, I don't have this side and this angle. I have this side, but not the same. Oh, I can't get this angle. See, all right. So it's all about, if I want to use law of sines, I need to be able to complete an angle with its related side, the side across from it. If I cannot get that, it must be either a law of cosines or just to warn you guys. What's that problem, Rio? Was it you? Were we talking about this problem?
57.
57 is a yummy one. 57 is neat. Let me ask you this. Just look at this problem. Is there any way to make a complete ratio inside of this triangle? Can I get a side and its related angle? No, it's impossible. There's no way. They only gave me one angle. I don't know its side. I don't know this side's angle. I don't know that side's angle. And I always get at least one person do some weird shit like this. They'll call this C, and then they'll think they'll figure out C. Is this okay? Why is this not okay?
It's not a right triangle.
Yeah, it could be, but I don't know. Right? It could be a right triangle, but I don't know. Too bad. Can I use law of cosines? Law of cosines would eat this thing up. No, because we haven't learned law of cosines yet. So that's why you got to do what they ask. And just to make sure you guys understand, let me get rid of all my shit. Hold on. Pop. So what does this mean? Draw perpendicular from N to LM. So what that means is, let me do what I learned earlier, or reminded myself of earlier. If I draw until it looks like it's about a right angle, sure, why not? Now I've created one right triangle, two right triangles. All right, that's all I'm going to say. It's not supposed to be an immediately obvious problem, but at least this explains what they mean by their hint. And then I'm going to let you guys try to do what you can do, right? Or you can just go, oh, I'm not going to even do this problem. Maybe you'll not even notice I didn't do it, Jeff. You feeling lucky. All right, let's see. I think I'm caught up on the chat stuff. All right, any other questions, guys, from anything? Any other questions? All right. All right, okay. So let's do this. I don't know if anybody's opened this stuff up yet or not, but if you go to, well, let me get this set up. All right, doesn't matter, Jeff. We'll do this. I'll become a student. No, become a student. So if you come on Canvas and you go down to Unit 10, you should see these two things. So let's open this bad boy up. Polar coordinates. Oh yeah, that's right. I need to prove those. Damn it. All right, so pull that up. You can print it out if you want to, whatever. So let me remind everybody where we left off last time. I guess I should turn off my Bryce Canyon in the background. Goodbye. Where'd you go? Oh shit, Jeff, you forgot how to do anything. There we go. Ah, there it is. Okay. Boop. All right. Oh, look. That's awesome. All right. I didn't use my whiteboard in my other classes, so that's perfect. All the stuff is still up here. We developed these to figure out, I don't know if you guys, so let me talk real quick about what we did yesterday. We have a rectangular coordinate system. Well, if I give you r theta, so that means go by an angle of theta and walk out r. Can we figure out what the x, y coordinates are for that point where I would end up? So polar coordinates are turn by this much of an angle, and then walk out this far, and where you end is the point. Whereas xy is walk this much, and then walk this much, and where you end is the point, right? Either way just finds a frickin' point. Okay, why am I so far away? All right, so we developed a way to translate from polar to rectangular. And it's not hard because it's just a freaking little right triangle here, right? So what would x be? What would y be? Come on.
R times cosine theta.
Again, cosine theta, think of it, it isn't this, but think of it as the percentage of the radius that falls in the x direction, or the hypotenuse, whatever you want to call this guy. It's the percentage of the hypotenuse that is in the x direction. So what about y? Y would equal r times
Sine theta.
sine theta. Because sine theta is the percentage of the radius or hypotenuse that lies in the y direction. I like it. And just in case, cosine theta, we defined it as x over r, correct? And if I multiply by r, I get here, yes? Not that big of a deal. Okay, I like it, Now, what if I go the other way? What if I give you the x and y coordinates? So I know what this is and I know what that is. And so I want to figure out what r and theta are. How the shit would I do that? Well, r is the easy one. Well, let's see. I don't know. Maybe. Well, it's got to be the easy one. What's the relationship between x, y, and r? It's in a right triangle, right? So what's the relationship between x, y, and r?
R squared
Yes.
equal x squared plus y squared.
Now, how do I figure out the angle? Somebody else. Right triangle, which means we can use trig directly. How do I figure out the angle? That one right there, that angle. How do I figure that out? Anybody? What do I do? There's a few different ways to do it, but there's a which way do I do it that isn't based on R? Because I don't know R to begin with. I actually have to figure it out. So I want to be able to figure out theta on its own. So what trig function do I want to use?
Tangent.
Tangent. Yeah, let me do it. No, I'm just going to jump straight to it. So the angle would be the inverse tangent of y over x, because the tangent of this would be y over x. Okay, is that all right? Okay, all right. So let's try a problem out real quick. So if I have the, let's see. Yeah, sure. Yeah, 5 square root of 3, negative 5. I like it. Now watch. Really smart idea. You don't even have to make a scale. Just where is this point? What quadrant would this point be in?
4.
Yeah, it's going to be over here and then down here. I don't need to make a. So I know it's in quadrant 4, correct? Yes. Yes. Now. So this is x. This is y. R is going to be easy. I mean, I didn't go this far, but r is the square root of that. Is that cool? So r is going to be easy. Figure out what r is, and then theta. Put these in the right way here. So all these they are just rules of how to convert from one coordinate system to the other. And the polar coordinate system kicks a lot of ass. Okay. Uh, 75 plus 25, and that's 10. I don't know if everybody got that. Did you guys get that? No, is that all right? No, you guys hate that? 5 squared is 25. Square root of 3 squared is 3. 25 times 3 is 75. Negative 5 squared is 25. 100 square root is 10. You guys okay out there? And then this guy, I would put y over x. People are really just a little too lax with this. Be careful how you put these in here. It's inverse tangent, so it's got to be y over x. So it'll be negative 1 over rad 3, which is actually something you should know. You should be able to figure out what angle that relates to. I mean, if you throw in the calculator, you're going to get the answer. What'd you guys get? Did anybody get this yet? You got to be careful, because I know I'm in quadrant 4, but what do I get when I throw this in the calculator? What do you guys get? Anybody? Anybody do that yet? Are you guys out there? Am I standing in my living room talking to my TV? Has it happened? Okay. Yeah, so somebody's helping me out. All right. So negative 30, which is okay. I mean, that's in the 4th quadrant, right? But it's a little more standard practice to give me a positive answer. So what would it be? What's this angle here?
Negative pi 6.
Say again? I like that even better. So this is negative pi over 6. So this will be 11 pi over 6. Pi over 6 less than 12 pi over 6, which is 2 pi. Yes. So what's the r theta here? R theta, the answer, let's collect what we know. It's 10, 11 pi over 6. So this is what it looks like in rectangular coordinates. That points to a certain point. And what's another way to get that same point? Tell somebody to rotate this much and then walk out this far. It gets you to the same exact point. Okay, maybe. Okay, all right. So let's do something. Oh, let me do this. All right. I'll let her move this farther away. If you saw this, can you translate that equation for me? What is r sine theta? So I want to translate from polar to rectangular. What is r sine theta in rectangular? You can do it. Sine likes.
Y.
See how much better that is than SOHCAHTOA bullshit? All right, sorry. So that's y plus
X.
x. And of course, r squared is
The sum of
so now
the
I've
square.
nothing but polar, and now I've got it in nothing but rectangular. Can somebody please tell me what this is the equation of? Can anyone figure out what that is the equation of?
Circle.
Circle. It's a circle that's been translated, right? You would subtract x and you would subtract y and you would complete the square. Oh, look at this beautiful shit. Complete the square. You get some numbers over there. You get like a shifted, what's it gonna be, Jeff? I don't even know. I think it's gonna be 1/2 and 1/2 and get out of there, square equals, I don't care. So it's going to be a circle shifted by 1/2 and 1/2. Okay, so somehow this equation gives me a circle. Yay, okay, all right. So let's do this. On the canvas, on the internets, in the same location. Well, no, I'm sorry. This sheet, the sheet I already pointed out. I'll catch up to myself. Let's look at these here. I'm going to open this up in a better way for me because it's all about me. Let me see. Where did I put you? Jeff, you dork. Hold on, everybody. You dork. Let me see. What is this thing called? Polar coordinates. Oh, that's easy enough. Of course, it's not here. I love it. I love that shit, Jeff. All right, let's download it. We'll save it. And we'll open it. And I don't want to open it there, you jackass. Come here, computer. Work with me. All right, there we go. It's just that easy, everybody. It's just that easy nowadays. Here we go. All right. Oh, I'm tired. So, let's see. Let's try number 1A out here. So notice it says convert to rectangular. So you know these are, so what is 2 and what is 5 pi over 3? What do they represent? Oh, Jeff, don't do that. What are they currently in? What coordinates are they currently in?
1.
Say it again.
1.
1? So are they currently
I was talking about terminal.
are they currently in polar coordinates or rectangular coordinates? Convert to rectangular. If they're in rectangular, then there's no work to do, correct? Are you guys with me out there? Are you guys all with me? Convert to rectangular, so they're currently in polar coordinates. So what does this tell me? What does this tell me?
Oh,
Yeah, R is 2. Now somebody else tell me, what's this tell me?
The angle.
Beta is 5 pi over 3. Okay. So I want to convert from polar to rectangular. So I want to convert to X and Y. Oh my gosh, Jeff. What I really want is just to be able to write. That would be amazing. Now, how do I convert? How do I get X? Somebody else that I haven't heard from yet. What would I do to get X?
You just put in 2 cosine 5 pi over 3.
Yeah. So here's how I get X. X is r cosine theta. So it'll be 2 times cosine 5 pi over 3. And normally I would put in the instructions, definitely for these, I would say I want the exact answer, right? Sometimes I'm going to give you weird ass angles that you have to plug in the calculator, but this is one you're supposed to know. So take a minute and figure out what that is. And of course, y is going to be 2 sine 5 pi over 3. All right. So this is basically a 60-degree reference angle, right? What quadrant is this in? 5 pi over 3. What quadrant is that in?
4.
Fourth quadrant. Okay, I like it. Which tells me that x is going to be positive, y is going to be negative, correct? Good. So for a lot of these problems, you do want to kind of draw yourself a little picture. That's really helpful to give yourself a visual anchor. So what's the cosine of a 60-degree reference angle?
1/2.
1/2. And then 1/2 of 2? 1. So what's the sine got to be then? If cosine was 1/2, sine of that angle?
Rad 3/2.
Good. And it's negative because it's down here, right?
Yeah.
So negative rad 3 over 2 times 2 is just negative rad 3. So this becomes the point 1, negative rad 3. I like it. So you guys do part B. All right, I'm going to kind of catch up to you guys. So x will be negative 12 cosine 7 pi over 6. What quadrant am I in this time?
3.
Yeah, I'm in 3, so I know they're both going to be negative. Both the x and the y are going to be negative. Well, all right. Let me say this. I just noticed something. All right. Maybe this is why, maybe we should, okay. Let me talk about this real quick. Which direction do I tell the person to face? I tell the person to face in this direction. Is everybody with me? Because that's 7 pi over 6. You guys with me? Where do I tell him to walk once he's facing that direction?
Like to the left.
Back. That's all. So look this way and walk backwards. So I want him to go 12 this way. So what's another way to identify this point instead of negative 12 comma 7 pi over 6? What would this angle here be? What's it got to be? You guys can do this. What's the reference angle here?
Would be pi over 6.
Pi over 6. So what's this angle got to be?
5/6.
Pi over 6, the same amount. Do you guys see that? So what's another? So if I have the point negative 12, 7 pi over 6, what's another way to reference that point? Positive 12,
5/6.
5 or 6. I really want you to understand this. So I can tell this poor person, I can say, okay, I want you to rotate 7 pi over 6 radians. Sure. And then I want you to walk freaking backwards 12 steps. Shit. Right? And so he'll end up here. Right? But if I told somebody, okay, I want you to rotate by pi over 6, and then I want you to walk forward 12 steps, they would still end up here. This is related to there being an infinite number of ways to identify an angle, correct? This is kind of like this whole thing. But now we're bringing in the fact that I can actually let R be negative. R could be negative, which just means it just means step backwards. So sort of if I said, okay, face north, now walk back 5 steps. You actually went south, correct? Okay, good. So this is saying face this way, but actually walk that way. Okay. I don't know. Are you guys okay with what's happening? A little bit? All right. All right, let's finish this out. So now I know the answer should come out to be positive because I'm in the first quadrant really. But when I do this cosine is 7 pi over 6 is going to be negative, but it's going to cancel with that negative. Does everybody see that? So it's going to come out in the end. So I know the answer is going to be positive. So I could just do 12 times. And what's cosine of 30 degrees?
About 3/2.
Yeah, let me make this really clear. So let me leave the negative there. And cosine of 7 pi over 6 is negative rad 3/2. The negatives cancel. 2 goes into 12 6 times. I get 6 rad 3. So that makes sense. 6 rad 3 here, right? 6 rad 3 here. Pop. And now I got to figure out what the y is going to be. So y is going to be negative 12 sine 7 pi over 6. And of course, what's the sine of 7 pi over 6 got to be? This was rad 3/2 negative, so this is going to have to be, if cosine was rad 3/2, sine's got to be
Negative 1/2.
1/2, the other one. Good, so this will come out to be positive 6. So 6 rad 3 over, and then 6 up. That'll be where that point is. So let's do this. I think I should have done this first down here. Let's do this. Isn't this cool looking? Come on. This is cool looking. It just is. It looks like it should start spinning and I go, you're under my power. But no. And let me show you real quick the other cool thing I did for you. I really think this is one of the better polar graph options that I found. You can actually Google image search polar graph and you can print out, but what I did on Canvas to help you out with your homework, you can just print out all these, you know, as many as you want, blah, 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 right? These are really cool. If you find one you like better, great, but I love this one because it really has a lot of detail where with what it tells you. Okay, so coming back. Jeff, where am I? I don't know, I forgot. I'm over here, that's right. Okay, let me do this. All right, so here we go. Let's all, yeah, this should have been the first problem. That would have made everything make more sense, Jeff. Oh, well, it's not like I'm a teacher. Oh, shit, I am. All right. So look at part A. Think about this as if you have a person standing right here facing 0. How will you tell this person to rotate? Whoa, somebody just came in, sorry. How much should they rotate by?
Pi over 3.
Pi over 3. So they're gonna face pi over 3. So they're gonna rotate to pi over 3. So they can be facing this way. And then how much do we want them to walk?
3.
3. So here's what we got to get used to. Oh, yeah. Where's the scale that I haven't identified yet? What scale have I not identified yet? I've identified the theta scale, which is basically set for everything. The angle scale is set. Where's my, so I always have XY scale, correct? You got to pick a scale for the x-axis, you got to pick a scale for the y-axis. R theta's set. These angles can't change. They are set. But R can change. Where is R? What captures the idea of R on this?
The inner circles.
The circles. I love it. So let's just go ahead and let's just leave it so I don't have to write anything weird. Let's just leave it 1, 2, 3, 4, 5, 6, 7. So this goes out to R equals 7. You with me? Is that going to work? Yes, because none of our R's is over 7. Beautiful. Is everybody with me? This is so freaking kick-ass. It really is. And hopefully somebody out there. All right. So if I'm facing pi over 3 and I want to walk 3, I just have to go 1, 2, 3. There's the point. Maybe. Now, real quick. I'm not going to do this for each one, but just for this one right here. What would the x coordinate be if I translate this into xy coordinates? What would the x coordinate be? It would be 3 cosine pi over 3, right? Come on, just go with me. Just go with me. This is so cool. Cosine of 60 is what? It's a nice one.
1 over 2.
Good. So this will be 1.5. Is that cool? 3 times a half, 1.5. What's it look like the x value is? Did I do this well? Who knows? Here's 1. Here's 2. Doesn't it look to be about 1.5? Like halfway there, roughly? Just go with me here. Okay. All right. All right. So because I don't know. I drew this a little bit big, but I won't. I think that also they maybe don't have this spaced out correctly, to be honest, but well, maybe it's okay. I don't anyway. So you can kind of overlay an XY coordinate system on top of a polar coordinate system and just everything should line up once you convert them. They should line up. Okay. I'll stop. You guys try to go ahead and do this one. This shouldn't be so horrible now, right? This is not bad, is it? This really shouldn't be bad. This is kind of nice. This tells you where to face, and this tells you how much to walk. All right, so where are you guys at? So you're going to face 3 pi over 2, and then I've just got to walk positive 4. So towards 3 pi, we're going to go 1, 2, 3, 4, so I'm right there. Pop. Okay. So that's easy. That was nice. This one is a halfway, but who gives a shit, right? I face pi. And I walk out 1, 2, 3.5. No big deal. No big deal. All right, this one. Same idea, really. I face pi over 6. So go ahead and try to plot this one. Go ahead and finish it up. Plot the rest of them. So r can be negative. Theta can be negative. So be careful. Oh, let me. A, B, C. Okay. So now I'm going to face pi over 6. And then I'm going to move 1.5. So 1.5. That's D. Boop. All right. So the first freaky one is E. It's not that freaky. Face 2 pi over 3. Turn to 2 pi over 3 and then go backwards. Because you're like, that's freaky. So you look at this guy, you're like, oh, you're freaky. I'm going to take 3 steps back. Now, here's the thing. Now watch. This is such an optical illusion. Which one of these is this line? I don't know if you guys agree with me. But the E is... Do you guys understand what I'm saying? So it's got to be across from the over 3 one over here. Does that make sense? It's got to be the same reference angle. So it's got to be, so that makes it a little easier. I don't know if anybody has the same issue I do. It's like one of those, here's a straw. Now, which one of these is the straw on the other side? I don't freaking know. But so there, I look for that guy. All right. So 1, I forgot already. Was it 3, 2, 3? Bam. Can somebody give me another way to identify point E then? What's another way to identify point E?
3 comma 5 pi over 3.
Kick ass. Somebody tell me another way. What about 3 comma negative pi over 3? Right, go back pi over 3 and then go out 3. All right, so there's several. I mean, how many ways are there? Technically an infinite number, right? Because there's an infinite number of ways to identify an angle. And then I can make freaking r negative, so there's like a double infinity. What? All right. So what about this guy? This guy's not too weird. I got to go back 11 pi over 12. So where am I going to end up? Am I going to go here? Yay. No, of course not. Where am I going to end? Right, here's 11 pi over 12. So I would stop here for 11 pi over 12. So where do I stop for negative 11 pi over 12? Right here. No? You guys hate this? Okay. So I face this guy and I walk 2 out. 1, 2. So that's where F is. Okay. So that's plotting points. Now, just to kind of, I know I want to do 2 more of these and then we'll call it a night. But just look what's coming. All right, you know this is going to happen. You know it, and you know you're going to be uneasy about this prospect. But remember how when you learned XY plotting points, and then the next thing you did was plotting functions? You have to know how to plot points before you can plot functions. So now we're going to have functions between r and theta, and they're going to have certain shapes that they normally come out to be. And this is starting to look like the spirograph stuff I was talking about. And you get these little, now of course this one's affectionately known as the butt graph. Poor little dude. Right, then you got the spiral, and then you got the inner whatever you're gonna call it. And this is always Mr. Peanut to me, I don't know. All right, this is the bike. That's not their official names, by the way. Please don't say that to a math person. ovals of Cassini, which is like, I don't even know Cassini. I'm talking about his ovals. So let's look at number 2. Look at 2A. Look at 2A. Oh shit, I missed the chat. I'm sorry, guys. Oh, that's from earlier. Okay. What? So it's sort of like the one I put on the board earlier. What is missing here? You know, I want to be able to convert this into X and Y, correct? What does this want to be? X or Y? What's it want to be? You could do it. You could do it. What needs to be here in between the 5 and the sign so it could become Y? What's Y supposed to have? What is Y? Have I been on mute this whole time? What's happening? All right. If I see R cosine theta somewhere, what can I replace that with? What is R cosine theta equal to?
X.
I saw Charles say it, but I can't hear him. But I'll give you credit for that. So what do I wish was right here in front of the sign?
R.
An R, because if there was a freaking R there, I could just put a Y there. So how do I put an R there? I could do it as an equation. I could put an R there. Of course I can. If I multiply one side by R, you got to multiply the other side by R, correct? So don't I end up with R times R squared equals 5R sine theta? You guys understand what's happening? That's the beautiful thing about equations. You're like, man, I wish I had this here, or man, I wish that wasn't there. You can kill it, or you can bring it into existence, right? You have the power. You are the creator and the destroyer, the alpha and the omega. Okay, I'll stop. What is R squared in terms of X and Y?
X squared plus Y squared.
And then what's 5R sine theta? What's R sine theta?
R.
Y.
Y. Okay. And again, this would be a circle again. So here, let me do this. I think we'll finish this next time. I want to show you one really cool thing that you can start doing immediately. You don't have to understand shit to do this. All right. I'm not saying you don't understand shit. Hopefully you understand what I'm saying, but I'm just saying you don't have to understand polar coordinates to start playing with polar coordinates. Now watch this. How do I change my calculator into a polar coordinate calculator? I go to mode and I pick polar. Holy shit. Parametric is something in our future. Yeah. So now if I hit Y, if I do this, hit go to mode and hit polar, when I go to Y equals, I get R equals. Look, I already have something in there. Isn't that neat? Watch this. Let's put in there 5 sine theta. And I need to make sure that I am in radians, or else things just go to shit. Trust me. So if you want to play along, let's put 5 sine theta in. And look at this. Isn't that cool? Let me do zoom 6 just to make it a normal. There we go. Why does it look like a football when I know it's supposed to be a circle? Does anyone know? Or the
Your
dimension?
scale is different.
Good. The dimensions of the XY screen are off. So this is a circle. It's not Stewie's head. Vile woman. I'll get you, fat man. All right, sorry. Now watch this. What if I put cosine in instead? What happened? Now it's a circle that basically opens around what axis?
EX.
X-axis. And when it was sine, it was a circle that opened around the y-axis. What if I put in there, stay with me now, guys. What if I put in here a 3? Let's see what happens, like sine 3 theta. What happens? Okay. Oh, sorry. Okay, little thing. What if I put a 4 in there? Okay. Well, what if I put a 5 in there? Oh, how many leaves are there? And by the way, let me show you this little cool thing. Go to Window, and do you see Theta Step? If anybody's playing along, if you make this smaller, well, Jeff, come on, you can do it, buddy. If you make this smaller, what the shit? Get out! Everybody, get out. Okay, if I make it smaller, it will do better resolution. See how it looks more curvy? So it seems, what does it seem when I put an odd number in here, I get that many leaves. When I put an even number in here, I get double the leaves. What? All right, and then I mean you could do some weird shit. You know, I don't know if anybody out there likes to play around with this stuff, but look at that. Well, that's a circle. That's boring. Wait a minute. I don't know what to do. Anyway, you guys can play if you want to. That would be Jeff in the corner with the calculator just playing around. I don't understand what I'm doing, but the pictures are cool looking. So you can get some cool looking pictures, and then later we can talk about why they came out the way they did. So you'll understand the reasoning behind them. Okay. Oh, dude, you're welcome. I love it, man. Sometimes things come together like that. All right, guys. Yeah, real quick. I love my computer programmers because here, last thing I'll show you. We'll see. Let's see if this is cool to you guys. I don't think I've shown you this yet. Well, let me show you first. Here's my Google stuff. But if you go to plot, not Okit, you go to if you go to plot.ninja. Have I shown you this guy? Yes, this yet? I did. All right. I just like to talk it up. It's not like I helped this guy, Nick Piscate. I always mispronounce his last name. He was a computer programmer. He was in my calculus course a while back, and he created this program because there really was nothing really good for 3D pictures. So look at this. So this is polar in 3D, basically. Woohoo! All right, that's it, guys. That's enough. So you're free to go. Let me know if you need to hang out. Oh, by the way, before anybody leaves, I'm gonna officially open the quiz at 7, and then you'll have until I don't know, 8 a.m. Saturday to get it done. Okay.
Thank you.
Welcome. So just give me a little while, and it will open at 7. Just got to get things set up. I forgot to get things set up. Does anyone need to hang out? You guys are all good? Go do that.
Have a good one.
You too. Have a good weekend, guys. I'll see ya.